With this angle, we are given 10, 15 degrees, right? And the question would want us to simplify this using compound angles. So how are we going to do this? Because we're only given 15 degrees. So 15 degrees is definitely not a special angle, right? So how are we going to tackle this? We know that compound angles is two angles, right? So somehow we want to write this 10 in this form. One angle plus the other angle. So it can be plus or minus actually. It can be angle plus minus another angle. But whatever we're going to choose, it must equal to 15. So A plus B should be equal to 15, or A minus B is equal to 15. Either and or, right? So how are we going to go about deciding which angles these unknown angles are going to be? Remember, when we're working with compound angles, we want to work with special angles, right? We trying to get angles that are special angles. That is the main reason why we are working with compound angles. So we want this angle and this angle to be special angles. So you can just choose any two special angles and see if they're going to add up or subtract to 15 degrees. And by the looks of it, we can see that 60 degrees minus 45 degrees, of which are both special angles. 60 minus 45 degrees is going to be 15 degrees, right? So yeah, we can go ahead and do this. But wait, with compound angles, so there's a certain formula that I forgot to include here. Because here, I just gave cos, sine, sine. But I only gave these ones for a very good reason, because there is an formula to expand out tan if there are compound angles for both plus and minus, but it is so complicated. Perhaps I will do it in another video and just show you, just in case you might be interested, but really it's just so complicated and long, and you don't want to worry about that. Maybe you do if you are an extremist, but let's just keep with simplicity. That's yes. So, but we know that tan, what is tan? Tan is sine over cos, right? So you're just going to say sine this angle divided by cos, same angle. And now there we go. Sine and cos, two angles. So we can use the compound formulas to replace the numerator and the denominator, right? Okay, so let me just put this on, let me just put it there, minimize it so that we can have space. So cool. Let's start with the numerator. Sine angle minus angle. Where is it? Sine angle minus angle. So we're going to use this form. Cool. So it's going to be sine 60 degrees cos 45 degrees minus cos 60 degrees sine 45 degrees. Same procedure down, but with cos. Cos angle minus angle. Cos angle minus angle. So we're also going to use this form. So it's going to be cos 60 degrees cos 45 degrees plus sine 60 degrees sine 45 degrees. And let us see. Now we all got them to be special angles like we want to, right? So sine 60 would be square root 3 over 2. Cos 45 would be square root 2 over 2 minus cos 60, which is 1 over 2 sine 45 degrees, which is square root 2 over 2, divided by cos 60 is 1 over 2. Cos 45, okay, we actually got it to be square root 2 over 2. Plus, what did we get sine 60 to be? Square root 3 over 2 sine 45 square root 2 over 2. Okay, let's go ahead and simplify. It's fine. Let me just continue writing. Okay, so it's going to be square root 6 over 4 minus square root 2 over 4 over square root 2 over 4 plus square root 6 over 4. So let's continue on that other side. It's going to be square root 6 minus square root 2 over 4 divided by square root 2 plus square root 6 over 4. We know that when you divide a fraction by a fraction and they have the same denominator, you simply just cancel them and you're left with those numerators. So it's going to be square root 6 minus square root 2, which is square root 6 plus square root 2. I just swapped them, but I mean, it's the same thing. Cool. Let me just try to move this a little bit on the side. Okay, so yeah, we have a situation where, is it simplified? It is not. So if the question says simplify, you gotta simplify to the fullest, you know. So why is it not simplified? When you see a square root at the denominator, you must just know that, okay, it is not simplified. That's the general way of saying, if you want something to be simplified, the denominator must not have any square roots. So how do we eliminate these square roots? Rationalization, right? Square root 6, square root 2, square root 6, square root 2. Opposite sign. So you're essentially taking these two terms on the denominator, dividing them by each other, but with a different sign. Because, you know, if you're going to cancel, it's just going to be 1. So you're essentially multiplying this by 1. Everything in mathematics is kind of multiplied by 1. You can think of it that way. This is just a fancy way of writing that 1. But we want to write it in this way to eliminate the square roots at the bottom. So if we're going to do that, it's going to be square root 6 minus square root 2, square root 6 minus square root 2. Two terms, different signs when you multiply, so you can just multiply first by first and last by last. First by first is square root 6, square root 6, which is 6. Last by last is positive square root 2, multiplied by negative square root 2, which is 2. Cool. Yeah, let's go ahead and simplify that further. So if you multiply the bracket at the top, it's going to be 6 minus square root 6 square root 2 plus square root 6 square root 2 positive 2. 6 minus 2, which is going to be, these cancel, so you're going to be left with 6 plus 2, 6 minus 2, simplify further, it's 8 divided by 4, which is equal to 2. So that is how you go from here all the way there to there. I know this one is quite long because of the 10 we had to change, but yes, you just want to keep on making sure you don't make mistakes as you go along, and just make sure you use the correct compound angle formulas. Thank you.